Okay, let's talk about limits. This is limits lesson 9.1. All right, here's how to say this. The limit as x approaches 2 from the left, or it's asking what is the limit as x approaches 2 from the left of f of x. I want to point out that this tiny little symbol right here doesn't really mean negative. It means from the left-hand side. If it was a tiny little positive symbol, it would mean from the right-hand side. What this is asking you to do is to analyze the function, which is here, and approach an x of positive 2 from the left-hand side. So you're writing the function until you are approaching positive 2. And the thing that you should know is that limits are about where you're headed, not where you end up. Okay? It's where you're headed. It's not where you end up. Okay? So as we stay on the function f of x, headed toward an x of 2, we are headed toward a y of there. When we arrive at 2, the function does not exist at -4. It exists actually right there. But because we are headed from the left toward x of 2, the y is -4, and that's the limit. Watch this little animation. You can see we're writing the function as x approaches -2. It never gets there. It stops, well, this animation, it stops at 1.99999. The nines go on forever, but that is the value you're approaching. The function is approaching -4. You see that visually. What is the limit of f of x as x approaches -3 from the right-hand side? So let's approach -3 from the right. Okay, so we're on the function and -3 is right there. So as we approach it, this is where we're headed. We are headed toward a y value of 5. Okay, and there's a little animation that does what I just did. Now, this is not a limit question. It is just asking, what is f of 2? What is the value of y when x is 2? And here's the function. Here's the other part of the function. When x is 2, not defined there, defined right there. And your y is 3. This question brings it all together, okay? F of x is all these little bits of lines and open and closed circles. Let's start with the first box, the limit as x approaches 2 from the left. So here's 2. When we approach from the left, we're clearly headed toward 1. And when we approach positive 2 from the right-hand side, that's what this means, we're approaching 3. Now, this question here would be stated the limit as x approaches 2, period. There is no little negative or positive sign right in this corner. So how do you answer this? Here's a very simple rule. When these two values agree, okay, that is your answer. If they disagree, The answer is DNE. Oops, I think I skipped something. Negative, maybe it was here. -2, the function when you arrive at -2 is -5. Okay. And try another table. As you approach 5 from the positive 5 from the left, here's 5. So to the left of 5, you've got 4.9 and 4.99, 4.99, 4.999, 4.99999. Okay, so seem to be headed toward a -1. From the other side, 5.1 would be close. 5.01 would be closer. 5.001, 0.00001. So that's also approaching -1. So following this rule, if the left-handed and the right-handed limit are the same, then the limit as it approaches the 5 period is -1. But when you arrive at that value of x at 5, it's also -1. Okay. This later you'll learn that this is called a continuous function. It's a very smooth line at that, at x equals 5. Okay. Lastly, okay, now we're not doing limits to a specific number. We're doing limits to infinity. So the limit of this mystery value of function as x approaches -infinity is what? Actually, I'm going to start with this one. Let's go to positive infinity first. How about 99? How about 999? Just get bigger and bigger numbers. Doesn't matter what you use as long as you make it gradual. This is, okay, I think this number is so large that it can't even round anymore. Or can't, it automatically rounds. There's so many nines in the decimal, so many decimal places with 9. It's too close to -1 to call it anything else. Okay, so that's positive infinity. What about negative infinity? We start with this, and then we go to that, then we go to this, then we go to something even bigger. Now, look at what's happening with the function. Oh, it's just jumping all over the place. It's not heading toward any, oh, and then it just dips out. So there's no clear pattern here at all. It's not heading toward any particular value. You're going to say DNE. Now, what kind of function even is this where the larger you get, it kind of just vacillates up and down? I'll tell you one such function. It's, how about a cosine or a sine graph? As this goes to, let's say, -infinity, and it continues to do all this, whoa, it's going to vacillate between two different values, not settle on any one. But this side of the limit, as x goes to infinity, y approaches 1, you have seen that, okay? Look at how this gets closer and closer to a y value of, I'm going to say this y value is, oops, sorry. That's an asymptote. And that asymptote is at y equals 1. So this is an illustration of how when the x goes to positive infinity, the function, and y is always about the function, is headed closer and closer to 1. Oops, what's my mistake? I think I was supposed to say -1. Okay.